Hello friends, welcome back to the next lesson in the time speed distance chapter. In this lesson we are discussing another important structure in time speed distance, although again it's important but you will not get too many questions on this. But you should know the basics because if any question comes on this, it will normally be pretty simple. And that concept is the concept of circular motion and the structures of circular motion. So let's start having a look at what we mean by circular motion, what are the structures and the constructs on circular motion, and how you build questions and answers on circular motion chapter. So when you talk about a circular motion question, there are 4 variables inside this question. Of course, the speed at which someone is traveling. Let's say a person A is traveling at a speed A, which can again be measured in meters per second or kilometers per hour based on a circumference of in meters or in kilometers, or it can also be measured in terms of percentage per hour or percentage per minute or percentage per second, because in these cases distance can also be measured in terms of percentage of the circular distance. So if I take the circle as 100%, then I can also measure distance as percentage in percentage terms. If I can do that, percentage per hour or percentage per minute or percentage per second is what will become for the speed units, right? So if you measure distance in percentage, measure speed in percentage per unit time. So apart from that, the other this thing is the circumference of the circle. As I said, that's the second variable, and it can be taken in both meters, kilometers, and percentage. And the third is something called TA, which is normally in these cases defined as the time taken by A to complete a round. Time taken by A to complete one round around the circle, right? So again, of course, the time taken by A can be in hours, minutes, seconds, depending on what you have taken for speed. So the units need to be consistent between speed and time, and logically the units for distance will also be consistent in such a case. Now the interesting part, I mean, if one person is running on a circle, it does not make many questions. But the interesting question structure or the question type here is if you have more than one person running around a circle. Let's say we have a situation where 3 people A, B and C are running around a circle. So the typical question you will get, let's say if I tell you that the speed of A is 20 kilometers per hour, speed of B is 15 kilometers per hour, and speed of C is 12 kilometers per hour, and they're running around a circumference of a circle whose circumference is 100 kilometers. So what will happen is you might be asked 2 questions here, 2 basic questions here. The first question is, and these are almost questions on circular motion when multiple people are moving around the circle, are about meeting points. So the first question would be one in which we are talking about, or we are asking this question about meeting at the starting point. After how much time will they meet at the starting point? So for that, what you have to do is you have to derive TA, TB and TC. Remember, TA was the time taken by A to cover the circle, TB is the time taken by B to cover the circle, TC is the time taken by C to cover the circle. So you derive TA, TB, TC, and then the LCM of TA, TB, TC would be the answer for the time taken for them to meet for the first time at the starting point. This has to be importantly added there. first meeting at the starting point will happen in the LCM of TA, TB, TC. So if you look at this question, the way you'll solve it will be that SA being 20 kilometers per hour and the circumference being 100 kilometers, A takes 5 hours, so TA is 5. B takes circumference being 100 kilometers and speed being 15 kilometers per hour, 100 by 15. TB, the value will be 6.66 hours. And TC, 100 speed, 12 kilometers per hour, 100 circumference, 12 kilometers per hour speed. So TC would be 100 by 12, which would be 8.33 kilometers per hour, hours. This is time, so the units will be hours. So that means TC is 8.33 hours. So if you want to find the first meeting at the starting point, it will be the LCM of TA, TB, TC. TA in this is 5, TB is 6.66 and TC is 8.33, which can be changed to 5, 20 by 3 and 25 by 3. And as you know, the LCM of fractions is taken by LCM of numerators divided by HCF of denominators. In this case, the numerators are 5, 20 and 25, and the LCM of 5, 20 and 25 is 100, and the HCF of 1, 3 and 3, HCF of denominators. This is the LCM of numerators, and the HCF of 1, 3 and 3 will be 1 itself, not 3, and hence they will meet at the starting point after 100 hours. And then you can have questions like how many rounds has A done, how many rounds has B done, how many rounds has C done. So if A is doing a round in 5 hours, in 100 hours A would do 20 rounds. B is doing a round in 6.66 hours, so in 100 hours B would do 16 rounds. And C has done a round in 8.33 hours, so in 100 hours C would do 12 rounds. Sorry, this would not be 16, this would be 15. So A would have done 20 rounds, B would have done 15 rounds, and C would have done 12 rounds. This is how you can find this out. Now, in case you want to, the other question that you get is the first meeting at any point on the circle. So let's go back to that, to an understanding of that. The first meeting at any point on the circle. A is traveling at 20 kilometers per hour, B is traveling at 15 kilometers per hour, and C is traveling at 12 kilometers per hour. So we are asking for first meeting at starting point, at any point. So in this scenario, what will happen is there will be, in this case, because A is fastest, as defined in the question, and also we know the circumference is 100 kilometers. Because A is fastest, the A would be overlapping each of B and C after some time. So we can define two times, TAB and TAC. TAB is the time in which A overlaps B or overtakes B. So what happens in a circle is A will go ahead, but after some time B would be running here and A would come from behind and catch him. So TAB and TAC would have to be found out. The time taken by A to overlap B, the time taken by A to overlap C, and for the first meeting at any point on the circle, not necessarily the starting point, the time required for first meeting at any point of the circle would be essentially first meeting at starting point at any point on the circle would essentially be the LCM of TAB and TAC. So the question arises, how do you find TAB and TAC? So for that, let's just look at this. A does a round in 5 hours, B does around in 6.66 hours. I'll just show you how to find TAB. You can use the similar thing with TAC and find out. But before I go there, one last thing here. LCM of TAB and TAC can be in language terms referred to as the LCM of the times required by the fastest to overtake each of the slower runners or objects moving around the circle. So A is the fastest here, so A overlapping B and A overlapping C. If there was a D also running here, then this case would be LCM of TAB, TAC and TAD. You'll have to add that if there was a D there, but there's no D here, so it will be suffice to say LCM of TAC, TAB, TAC. So how do you find the TAB? That's the last part of this thing. And then you're ready to handle the questions which we will have put in the assignments. You can work on those and simplify your thinking on circular motion so that you can handle this question type. As I said, not much effort required in this. Just make sure that you have done enough to do the basic questions. In aptitude exams, you will not get very twisted questions on circular motion. So we knew that speed of A was 20 kilometers per hour, speed of B was 15 kilometers per hour, and speed of C was 12 kilometers per hour. And we also knew that the circumference was 100 kilometers. We also knew the circumference was 100 kilometers. So in this scenario, the way you can solve this is simply that in this case, because A and B and C are also all three of them are moving in the same direction. So you can use the concept of relative speed here. And the concept of relative speed will work this way, that if A is traveling at 20 and B is traveling at 15, the relative speed is 5. And 5 into T has to be the distance. And for that this T to be equal to the time taken by A to overlap B, the distance has to be taken as one circumference of the circle. So in this case, the distance becomes 100. And what you can make out is that A overlaps B in 20 hours in this case. And likewise, A overlapping C, A overlaps C would happen at a relative speed of 8 kilometers per hour into time AC, which is the time A takes to overlap C, has to be equal to 100 kilometers, because the circumference is given as 100. If this was given as 80, you would have replaced this by 80 and this also by 80. But anyway, let's solve this, continue solving this with 100. So the TAC in this case would become 12.5. So the first time they'll meet together at any point of the circle will be the LCM of TAB and TAC. In this case, if you take the LCM, it comes out as 100 in this case also, which means that in this scenario, ABC are meeting for the first time here only. But this is not always true. Sometimes you might get a case where they're meeting or first time they're together at any point on the circle is some other position apart from the starting position. It can happen. It does happen in questions. This is just accidental. So the process should be clear to you. And with that, I will wind up the circular motion part of this chapter. Please go ahead and solve the questions and make sure that you get a grasp on how questions are framed in this area. So that's it for now. I'll see you in the next lesson, which is the applications of time, speed, distance. So new chapter there. Right? Bye bye.